Just okay. Can you see my screen?
Perfect.
Okay. So nice to meet everybody. My name is Michelle Gutzeit, and I'm located in Montreal, Canada. Even though I'm in Montreal, I don't speak French very well. I just understand. So this is why I'm presenting today in English. I'm a Microsoft Data Platform MVP with 33 years of experience in IT and 23 years experience with SQL Server. And these are my email addresses. So feel free if you have any questions or if you need to, if you would like to comment, feel free to email me. I know this is about the Power BI and reporting and analytics Saturday. I've been working a lot on the data platform side on Azure, and I realized that a lot of the clients, a lot of my clients, they accumulated data over the years, and there's a lot of data, and there are a lot of systems. And the problem is that as we accumulate data, we start seeing a lot of problems. So I decided to create this presentation to discuss the options of archiving data into Azure. Even if you have other platforms, I'm going to talk about SQL Server, but there are, even if you have other platforms, it's more or less it's similar if you wish to move from another platform to the cloud. But I'm going to focus on SQL Server and Azure. So let's start. So I'm going to talk about your potential current environment. You may have only one server that you manage or develop or have to create reports from, or you may have more complex environments. So I'm going to talk about what you currently potentially have. I'm going to talk about the potential problems and potential goals that we have around the data. I'm going to talk about historical and read-only data and the characteristic of that data. I'm going to discuss the options and methodologies to archive the data into either on-prem or in Azure. I'm going to talk about advantages and disadvantages of each. I'm going to talk about a little bit about the pricing of the options. And that's it. So let's talk about your potential current architecture. So like I said, you may have only one instance or two instances or very few instances with few databases. But even if we have one or two, sometimes the data is so large that we have a problem managing the data. But what if, for example, this is how your environment looks like? What if you have so many instances and servers and potentially in different data centers or different locations, potentially in different countries, potentially you have data that is dependent on other data, either locally or remotely. So that really complicates the things, because when we're talking about archiving, we need to take into consideration the entire set of data and all the dependencies and where the data is located and the DR, everything that we have in our environment. And maybe your environment is as complicated as, maybe you have different sizes of servers, maybe even different editions of SQL Server, which makes it a little bit difficult to have one solution for everything, because you do have some features that exist in different editions of SQL Server. And maybe your environment is as complicated as having so many versions of SQL Server, service packs, cumulative updates. And by the way, the last one, SQL Server 2020, is just a bad joke about COVID. So we don't have that one yet. Hopefully we will not have. So your environment may be very complicated in terms of a lot of servers, a lot of editions, a lot of versions. And let's complicate even more. Maybe you have physical environments, virtual environments in the cloud, or virtual machine in the cloud, and even databases in the cloud. And maybe your environment is as complicated as having multiple cloud providers, like maybe you have a footprint on Azure and on Google, on Amazon, maybe other private clouds. So it's becoming more and more complicated, and we need to take into consideration everything. And maybe you even have servers where you have multiple instances installed. So when we were talking about archive, do we have to take into consideration the dependency between the instances, if there are any? So basically, with Microsoft, with SQL Server, we can have a database everywhere. So it starts from physical servers on-prem or in your specific data center. But on top of this, we have potentially virtual machines. Maybe you have VMware, when maybe you have Hyper-V. On top of this, you have the cloud. So you have VMs in the cloud. You have database as a service, PaaS solutions, and maybe you have software as a service. With databases that you actually need to take care of the read-only data. Usually, the software as a service, you are not managing this, the data, so it's being taken care by whoever is taking care of your data. So I'm not going to talk about the service, software as a service. So from application point of view, it doesn't really matter where your database is. And some of the solutions that I'm going to talk about are relying on that. And there are additional setup considerations that we need to take into account, which is, for example, the network setup. What is the network setup that you have? Do you have any security constraints on the network? Because we're talking about cloud, we're talking about data that needs to be moved to the cloud. So what is the network setup from security perspective and from bandwidth perspective? What are your security constraints? It really matters when we archive data, where the data resides. So security is very important. Do you have legacy applications, for example, where your application server has to reside along with the database server? Is the application even compatible with you archiving the data? Do you have any third-party applications where you need to archive data and you need the vendor to approve this archive process, or even be part of it? And what is the support that you're getting if you archive data? Are you still getting support from the dev team or from the vendor? So we need to take all of this into consideration when we talk about archiving. So usually when you're talking about archiving, is because your database is actually a ticking bomb, and I try to make like a fat database here that is about to explode. So usually we're not thinking about moving data unless we really need to, right? So let's talk about what are our potential problems and potential goals when we're talking about archiving data. Disk space issue, if you have data on-prem, for example, and you need to purchase additional storage. As the applications grow, you may require more and more storage, and you need to free up space on the disk, right? I have a lot of clients that most of the problems are disk space issues, and they keep cleaning up and cleaning up and cleaning up, and it's a never-ending story. So is that your problem? Do you have an old hardware that needs to be replaced? For example, let's say if you have machines or storage that requires to be replaced, maybe they're no longer supported, or they're too slow for you. Do you need to scale your environment up or out? Like, do you need better machines, or do you need bigger machines, or do you need to add machines to your environment? Do you have performance issues? Usually this is the disk space and performance are the main drivers for archiving read-only data or data. What about the maintenance and support? You have large amounts of data. So everything becomes a problem, even just doing re-indexing or checking databases with DBCC CheckDB. Everything becomes very, very problematic. Okay, so stuff may be running for a long time, all the maintenance, maybe even failing for different reasons. So is that your problem? What about the fact that you actually need to create a new reporting or analytic environment with the data from the source systems that you have? Do you have to centralize data? Do you have to make sure that you can have like a high-level vision of the data for analytics and for trend analysis or for machine learning or anything else? Do you need to keep your data for auditing purposes? For example, I have clients that they have, let's say, data for the last 20 or 25 years, and they actually don't need the data from, let's say, 2 years ago and older, but they do need to keep the data like forever for auditing purposes. So is that your environment? Do you need to cut costs? So for example, do you have 25 years of data, and do you need to make sure that you're not upgrading your environment, or that you don't buy more hardware, or you don't need bigger machines in the cloud? Is that your problem? Is that your issue? Are you thinking about modernization? So are you thinking about moving to the cloud, with the new analytics tools? What are you thinking about? Maybe you have legacy applications that requires to be migrated or upgraded, but they're too big. Maybe it's the time to clean up a little bit. And maybe you have a different problems and goals. So, but those are the main drivers that I've seen within my customers. So let's talk about the read-only data, okay? Because we have data, but what about the read-only data? So this is a very delicate topic, because what is the read-only data? In some of my clients, they don't even understand how is the data used. So they have big databases, they have huge amount of data sets, but they don't actually know if the data is read-only or updatable. So the first thing that we need to do, if we're not sure, is identify the characteristics of the data that we need to shrink, okay, or to move, or to copy, or to archive. So are we actually updating the data? So we have few options. Either we never update the data. So it's very easy to archive data when your application, when your database has inserts of data that will never change, right? You're inserting data and it never changes. This is really easy to archive. You just take the older data and you can place it somewhere else. But what if you do have read-only data that can rarely be updated? How do you update? So if you store it somewhere, how do you actually update? And what if you have very old data that can be updated on a regular basis? This can be very problematic, because you cannot say this is my read-only data, because it's not read-only. What is the importance of performance when you're querying the data? So if we have 25 years of data, is it actually important that if I need a record from 20 years ago, is it important that it's real time? Or can it take some time? Can the performance be degraded a little bit? Can I say, okay, this data is being archived and it will take me 2 days to get this data? Is that okay? So what is the importance of getting the performance? What is the importance of the current performance of getting this data for you? And where is its data going to be queried from? So let's say I archive the data. Is it still going to be able to be fetched by the OLTP application? Do I need to do reporting on data that is 20 years old? Do I only need to do analytics and reporting, or trend analysis and stuff like that? Do I query this data from everywhere, like OLTP, analytics? Do I need this data just there for everything? Do I need it only for auditing purposes? So basically, if you have, let's say, pharmaceutical or medical data, and you have you've been audited, so when the auditor comes, you can provide them the data, but it can be archived any time other than that. So is that what's happening in your environment? So not everybody can go to the cloud for different reasons. And also it's very important when you go to the cloud to make sure that your data resides wherever it needs to reside. Just an example, if you're hosting your data in a different country, that different country may have different rules regarding the accessibility of your data. Just an example that I know of is that if you place your data in China, in Microsoft data center in China, China has this government law that the government can access your data if it resides in China. So do you want that? So you need to make sure that from every perspective, security, other maybe other perspective, you can move to the cloud or keep your data in the cloud, maybe totally, maybe partially. So we need to identify what we can do and what do we want to achieve, and the way that we can archive the data based on performance and what we do with that data. So let's talk about the goals and objectives for archiving or moving read-only data or data. So let's talk about the potential archived data locations. So usually when we're archiving data, our main goal would be to move the data away from the OLTP. So when I'm talking about away from the OLTP, it just to make sure that it's there, but it will not affect the OLTP environment. So I'm going to talk about some options to do that. And do we need to keep the data handy? We do, but maybe different levels of being handy, right? Like I talked about before. It could be handy within a few days or real time. And what is the accessibility to the archive data? Do we need to do real-time queries? Do we need to are we allowing degraded performance of the archive data or the real read-only or whatever we're moving? Or is it rarely queried? Okay, this means that rarely queried could be never queried, but has to be there just in case. Do we have any updates? This is very important. Do we need to update the archive data? This is very important when we choose the solution, okay? Because when we archive, some of the archive methods will not allow us to update the data. And based on your environment, is it simple? Is it complicated? Do we have, like, can we get a solution that fits everything? Maybe you will need to have different solutions for different environments. So I'm just going to lay down the options, and maybe you have one environment that you're going to use one option, and another environment with other option. So this is important to understand if we are going to use the same solution for everything or not, really depending on your environment. So let's talk about the options and methodologies. Remember when we archiving data or moving data, we are copying data to another database or another location. I'm going to talk about the location, and we need to delete the data from the original database. So this is like the basic of archiving data or moving data. You need to move the data, copy over, make sure that everything has been copied, and then you can delete it from the OLTP, okay? But it's still accessible to you, just in a different location. So it may be that your copy of the data will be either on a cheaper storage, because what we're trying to do, we're trying to have archive. We need the data handy, different levels of handiness. It could be on a cheaper storage. It could be on a cheaper hardware. it could be in the cloud. You can even do like a backup database and drop the database and keep the backup just in case. So I'm going to talk about those things. And table partitioning in SQL Server can be used to avoid contention. So I'm going to talk about table partitioning, but it's not a must. So table partitioning for me, when you have large sets of data, it's something that can accomplish a lot of things. I'm going to talk about that, and I'm going to show some examples. And this is to avoid contention when you delete the data. Okay, because imagine you have to copy the data over and then you have to delete. If you're using partitioning, it's very easy to remove data from your database, but not necessarily, really depending on the solution. So I'm going to talk about all that. So I'm not going to talk about how to copy the data. I'm just going to talk about the ways to archive the data. But basically, in a nutshell, if you want to talk about how to copy the data, you can use script and jobs. You can use SQL Replication or another third-party replication tool. You can export or BCP, depending on the versions that you have, depending on the environment that you have. You can use SSIS to copy over data. You can use the Azure Data Factory, or if you're in another cloud, like for example, Amazon, you can use other tools, right? And you can use other ETL or ELT tools or whatever method that you want to copy the data. Remember, you need to copy the data over to the new place and delete it from your existing database. So let's talk about the options of moving the data away from the OLTP, but still keeping it handy. Okay, so this is the presentation. The presentation is about that. What is handy? Handy means that if I need the data, it's there. Okay, we don't know if, so depending on what we need to have it handy real time or within degraded performance and so forth. So the idea is that we have the options that we have is, for example, use the same database. So keep the data in the same database, but on a separate storage. Okay, so some examples will be table partitioning, separate files and file groups, cloud storage, and stretch database. And I'm going to show you how it would work. And then it could be in a separate database, not the same database, but separate database, or separate files. And I'm going to talk about the advantages and disadvantages of each method. So let's start with the same database and same storage. Table partitioning. So if you're not aware of table partitioning exists since SQL Server 2016 Service Pack 1. It's also part of the standard edition of SQL Server. And what it allows, and before that, it was only Enterprise Edition. So let's say that you have large table or many large tables. You can keep the data of each, let's say, day or month or year separately on a separate file. So as you can see, I have a portion of the data from that large table in a separate file group. In this example, I'm talking about data per year because it's easier. I don't want to lay down, every month. So let's assume that it could be also by month or by week or even by day if you have large sets of data. So in this example, I have the data of 2010 in a separate file group on a separate file. So this is database file. So the file is the physical the physical storage of that portion of the data. So these are the basics of the table partitioning. From the application perspective, this is transparent. So the application will just query the large table. And based on the query, let's say if we're partitioning by the date, like here, or a date, then from the query, if you query by date, SQL Server will know which partitions to query. Even if you don't have the date, it will work in parallel to scan everything. So from performance perspective, it's going to be better even if you scan the entire set of data, because you can do things in parallel. Okay, so this is the large table, and you can partition all the tables if you wish. Okay, usually my rule of thumb is based on the performance, right? I would partition tables that have maybe 5 to 10 million rows and more. Okay, and really depending on your application and how you, how performance is. After you exhausted everything else, you can try partitioning. So because we're talking about separate physical files, what we do is we can actually place the historical data. So we still have everything in the same database, but we can place the historical data on a slower drive to save costs. Okay. And that is only assuming that when you query the data, you are usually going to query the recent data. Could be 2021, could be 2020, on a faster drive. So if your application, for example, is mostly querying the recent data, this is a very good solution for you, and you save cost because your storage can be something not fast. So you save cost on the storage. And if you want, you can do the same thing, but store your files in a blob storage in the cloud. So in this case, the performance of querying the older data will be degraded. And this is only if you don't query this and you don't need like good performance of the older data. Okay. But this is also a cheap solution. You don't need to buy hardware. So imagine that your data is growing, right? So in 5 years from now, you will want 2021 to also be in the cloud. So blob storage is a very cheap solution for you to keep your database files, but degraded performance. Okay, it really depends. So you need to have ExpressRoute to with the good network bandwidth to the cloud, and in some cases the performance will satisfy you even for the older data. So let's talk about the advantages and disadvantages. So advantages of table partitioning is improved performance. That's by table partitioning, but it's going to be improved performance because for the recent data, right? Also, you can decide that some of the files can be read-only. Some of the file groups can be read-only. So when the files are read-only, SQL Server does not have to hold the locks the same way on that data. So you may get a better performance. Also, if you have read-only file groups, you can back up the file group that is read-only once, and then make sure that your backups do not include the read-only files. So there's if you look at books online, Microsoft explains how you can back up your database when you have read-only file groups. So your backup is going to be faster and is going to be smaller. So you don't have to back up the entire database. With table partitioning is if you do it properly, okay, because you may do table partitioning but not properly. This is a topic for an entire presentation. But if you do it properly, it's very fast to move data with partition switch. So what you can do, you can just take the entire partition and switch, and it's a DML, it's a DDL command to just switch from one table to the other. So instead of copying over, which takes a long time and uses a transaction log, you just switch the partition to another table and you just copy that data over to whatever. So it's very fast to move the data from the database to your archive. So when you delete data, let's say that you don't have data table partitioning and you delete data, the delete is very resource consuming, and it also causes blocks and locks. With table partitioning, because it's a DDL, it's just structural change. It's very, very fast, and it's not the same. You don't going to lock the data as if you were deleting. So it's very fast move. And also, when you partition the table, you can do maintenance per partition. So it's faster on the maintenance as well, especially if you have read-only file groups. The disadvantage is that in some systems, it's very hard to find the partition key because you need to partition the data by something. If you have a date that is not null, it could be a good candidate. But even if you're using the date, you need to make sure that when you partition the table, the partitions are going to be more or less of the same size. Because what will happen, for example, if you have a table where you want to partition by year, but the 2021 is like huge and the rest is very small, the data set. So you need to try and find the right partition key and the right way to partition the data. You can partition, for example, you can say, okay, the first 10 years of my data will reside in one partition, and then you can partition even by day. So you have a partition function and partition scheme, and you can partition the data differently. You don't have to just choose 1 year across the board. It can be 10 years together, and then 1 year together, and then 1 month together, and then 1 day together. So it's challenging, and also the problem is that the partition key, if you want to do partition switch, the partition key needs to be part of all the indexes, including the primary key. So imagine that you have a primary key that is an identity column or like some number. You need to add the date in the primary key, and that means that you're losing your uniqueness. So if your application relies on the database for uniqueness of the primary key, you may need to do make some changes, maybe using triggers or something like that, which may degrade performance, to make sure that the uniqueness is still kept. You have more maintenance when you partition the table. You need to make sure that you always have the newest partition. So for example, when 2021 ends, you need to make sure that 2022 partition is there. So it's a little bit of maintenance, even though you can automate that, but you need to make sure that you're maintaining your partitions. For example, if you're partitioned by 1 day, you need to make sure that you have, for example, enough days, partitions that are empty to get new days. So it will need to run constantly to make sure that the new day is there from partitioning perspective. And there are also some constraints. Like I said, all indexes need to include the partition columns. Just read the books online, really, and you can find a lot of material around table partitioning and constraints. Let's move on. So what happens if, for example, we don't want to use table partitioning, and we have older version of SQL Server and we cannot upgrade and we cannot use the table partitioning? So another way to do it is you can create actual tables. So in this example, again, I'm talking about 1 table per year. You can do whatever you need. For example, I have a client that partitioned the data by, they had the identity column for the row, like record ID, and they partitioned by that, okay? So it really depends on the data, how you will partition. In my case, you can create a table per year, for example, and you can place a table, the entire table, in a separate file group and on another file, on a physical file. So it's the same concept, okay? We just have separate tables per partition, okay? And it can be on a fast drive for the queries, the data that is more recent, and the archive data can be on a slower drive. And the way if we need to review, if you need to query the entire set, we can actually use views because everything is in the same database. And as you can see, you can still make sure that those files are read-only. So it's going to be better from backup perspective and also from performance perspective, even though we're allocating this data on a slower drive. Okay, so this is another way to archive data, still keep it in the same database. So it's going to be handy, more closer to real-time queries, right? But we cut costs using slower drive. There are some constraints doing things through the view, but it may be a good solution for you for data archiving. And we can do the same thing, allocating the data physically on a blob storage in the cloud. So here's an example. I'm talking about, I keep talking about blob storage in the cloud. So Microsoft has a lot of information about this. The beauty of using Azure Blob Storage is that you just have to create a storage account and a container in Azure. And then you create a credential like the example here. And then you can actually create local database and place the files in the cloud in Azure. And you can do this, for example, you can have a hybrid database where some of your data, like I showed before, so it may be your primary file groups or your most recent file groups are located on-prem, and you locate different file groups in the cloud. So this is like a very flexible way to place your files, your database files everywhere, right? You can do it either locally or you can do it in the cloud. And if we're talking about cheap storage or a share, you can always map a share, right, to your machine and place your data anywhere. So this is a very nice flexibility that SQL Server has. And I put the link here in case you need to review how to do that. So this is the way that you refer to a blob storage in your for your files. Let's talk about the advantages and disadvantages. So improve performance of your main file groups because you have so of your main tables. So let's say that you use this architecture. You can have different type of views. So you can have a view for everything, and you can have a view for the recent tables. So this way you can manage performance better. Let's say that your OLTP environment, when you need updates and you need data updates and you need real-time queries, you use one view. But when you need your historical data, the entire set, you use another type of view or another view. Like I said, you can create read-only file groups, and therefore the query performance and the backups are going to be much better and much faster. You can still use partition switch, so you can if you have SQL Server 2016 Service Pack 1 and over, even in Standard Edition, you can still do partition switch of an entire table. So instead of copying, or you can just switch so that you know, if you need to copy data, so it will not be part of that view. You can always change the view. So for example, if you want to copy table 2010 somewhere else, you can either modify the view not to have this table, or you can switch partition. You don't have to change the view, so the table will be empty. So you switch the entire partition to another table, and then you copy the data from there. And it's going to be faster maintenance per table because you're just going to reindex or whatever you need to do, update statistics per table, per smaller table. But again, it increases the maintenance. So this is not really transparent. You still need to take care of the underlying tables and the views that query. So it's a little bit more maintenance for you. And there will be some constraints because you are actually, if you are using views to do some stuff, you need to make sure that you actually can do things via the views. But you can also do directly on the table, right? So if you name it properly, for example, recent table, you can always access the table, the recent table directly. So it's just another option. Let's continue. So what about same database and stretch store? Let's talk about the stretch database. So this is something that you have on Azure, but you don't have on any other cloud. And let's see how it works. So you have a database, SQL Server on-prem, with, let's say, tables, okay? And you also have Microsoft Azure, you have a subscription, and here's the application. So the way that stretch database works is that you have to choose the table that you want to stretch. And what happens when you stretch, you tell it, okay, you give it a condition, and the data that apply to that condition is moving to the cloud, but transparently to the application. So the application sees the order history table, but when you query older table or older data, it will go to Azure. Okay, so you may have performance degradation because you're going to Azure, but from the application perspective, this is very transparent. Okay, so this is a good thing if you can do it. But let's talk about the advantages and disadvantages. So this works for any edition of SQL Server, and it's really transparent to the application. It's slower access to the older data, but the backups are not included. So any data that was moving to Azure is being backed up on Azure. So you know that off the box, you have backups on Azure. So your backups are going to be smaller. The big problem is that there are some limitations. So some blob data types are not allowed. And also, if you look at books online and information, you just Google this information, you have some constraints in that. So for example, text and text, and some of the data types cannot be moved they cannot be using, if you have those, you cannot use the stretch database. So that's a big limitation. The biggest problem, I think, is that once you move the data to the cloud, so if you, let's say you have a condition that data older than 2020 is moving to Azure, once it moves to the Azure, you cannot bring it back, okay? So you cannot update the data. So we need to be very careful with this solution. If you want to bring data back, you have to copy the entire set of data and recreate the table. So that's a big limitation, but it may be good for you. If you know that you have tables where you only insert data and never need to bring back the data on-prem, then it's a good solution. Okay, so that's the stretch database. Let's move on. So what about separate databases? So I talked about keeping the database in this the data in the same database, but in a separate location. Okay, what about keeping the data in separate databases? So it could be under the same instance on-prem, so the same instance or separate instance, or in the cloud. So let's see what we can do here. So we have the instance on-prem, for example, and we have database file with like the database with the information from 2020 and 2021. Again, it could be by month, all right? It could be by day, depending on your data set. But I want to make sure that my older data is still there, but it is in a different database. So those databases are still under the same instance, but you see I have a database per year or per month or per day. And the database, it's the same concept. The database, the file group, the database can reside either on the cloud or on a slower drive, okay? But it's under the same instance. So I have a database, a main database, the primary database with the data that the OLTP data, and my archive data is in different databases per year or per month, placed on a cheaper storage, either blob storage or slower drive. But if I need to query this data, I can use views and synonyms from that database, right? Or I can use the three-part naming. So I can access from this database, I can access because it's under the same instance. So this is a nice way to keep this data. If this is read-only data, I only back it up after I create this database, and I don't need to continue backing it up. I just continue backing up my OLTP database. So again, advantages, improved performance because my main database is tinier, it's faster maintenance, faster backups. We don't need additional license costs because we're keeping the archive databases under the same instance, so I don't need a new instance for this. But the disadvantages is, again, depending on how I partition this data and how I need to copy, increase maintenance. We will have some constraints because we're using views and synonyms to access the older data. But in this case, for example, if you need to update the data, and I haven't talked about that previously, but first, with some of those solutions, even if I need to update the data, if the file, if it's not read-only file group, I can still update the data. It's just going to take maybe longer, and it's going to be on a slower storage or in the cloud, but I can still update the data, really depending on your needs. Potentially, when we need to archive the data, we're going to copy data to another database, which is local, so it's going to be easy. You just have to use the 3-part name, and again, it really depending on your needs. Let's move on. So what about having a separate instance on-prem or in the cloud? So this is separate instance. So before I talked about separate databases under the same instance, this is a separate. So remember, our databases can reside anywhere. So it could be in another data center. It can be in the same data center, different instance. It can be managed instance. It can be Azure database. It can be another VM in the cloud. So basically, you just have to move the data over, and because it's a database, it's still going to be handy for you. So it's really easy to query from the OLTP, and obviously you can use linked servers or views and synonyms if you need to query the data from the database, or you can actually query the database from the application directly. So it really doesn't matter. You can just move the data from your local instance to another instance or to the cloud PaaS solution or IaaS, and query the data. So the advantages and disadvantages, again, everything improved performance, you have faster local maintenance and backups, and the disadvantages is that your data resides elsewhere and you need to maintain the archive process, and you have some constraints when you're using linked servers. Maybe the data updates are not going to be done the same thing if you need to update the data, and potentially decrease performance using linked servers. And more methods, for example, since we're moving the data to databases, we don't have to keep the actual database alive. Really, if you were, for example, if you need to archive only you don't need read real-time queries, or you don't need to query the database. You can actually just back up the database either on-prem or in the cloud or wherever, and just keep the backup file just in case. Okay, so let's say that 2010 and 2011, there's no chance that you're going to need it from the OLTP. You back up the database, you drop the database itself, so you don't have to pay for that, and you just keep the backup file just in case. In case you need to restore, you restore it, and you just have the data handy, right? Another way to do it is, for example, if you're using the cloud, if you have a virtual machine with SQL Server in the cloud, you can stop the resource, right? It doesn't have to be up all the time. So if you don't need the data, you can just stop the resource. And if you're using serverless, means that you pay for what you use, you can keep the database in the cloud and only use it when you need. So you only pay for what you use. So it will look like this. You will have database in the cloud, or a virtual machine in the cloud with 2010, 2011, 2012. Okay. And so this is when you actually don't need the data handy all the time. You can just stop the resources or backup and drop. Let's talk about separate files. So I already talked about the backups. You can also export the data into CSV files or other formats, okay? And I'm going to talk about a new way to do things, also thinking about modernization, okay? So in terms of storage, we can always use the on-prem storage. It could be cheaper storage, right, for the archive, or cloud storage. And from file types, We can, I talked about backing up and dropping the database, so we can keep backups. It could be a VM snapshot. It could be any type of backup that you can restore fast or not fast, depending on what you need. But the data is not handy. Let's talk about exporting into other formats. So the way that we know how to export data, and we knew until now, was CSV and text files, okay, from SQL Server perspective. But CSV and text files are not compressed. So now we can export the files in JSON and in Parquet file, which is very, very compressed. So Parquet files are the new modern way to keep data. And we just keep the data in a Parquet file that can be queried. Let's talk about this. So the way it works in Azure is that the basic of the process is that you have on-prem SQL Server database. You're using Azure Data Factory or any other ETL, ELT tool to export the data to Blob storage, okay? And the best way to keep it compressed is to keep it in Parquet files. So the way it would work, let's talk about, let's assume that our table is partitioned because it's easier to show. So the same partition per year, and we have the data lake generation 2 blob storage. So it's not the regular blob storage, it's the data lake generation 2 blob storage, which is very cheap storage. I'm going to show. So what you do is that you use Data Factory or any other ETL, ELT tool to export the data into Parquet files that are going to reside in the data lake. And the beauty of this, I'm going to show the entire process, is that you can still query this data in T-SQL, okay, using Polybase. So this is performance of this query may be very, very slow, but let me show you what we can do. So so once we move the data to the Parquet files, we have to drop the partitions, obviously, because the data is here. And by the way, this is optional. I have clients that want to move to Parquet files in the cloud for analytics, for example. So they actually don't delete the data from OLTP if they partition the table and it works for them, okay? So this is optional. So I know it's a very complicated diagram, but let's see what we can do. So this is our application, and this is our OLTP database. And so what we can do is we can use ETL or ELT, like Data Factory, and move copy the files over in Parquet files into the data lake storage. And then we can, with Polybase, okay, with Polybase here, we can have views using Polybase to query this data directly. So you can actually, with Polybase, you can use Transact SQL to read Parquet files. That's amazing. The performance may be really slow. Do we care? If we care about the performance, we can always map those files to Azure Synapse, and then with Polybase we can query Azure Synapse that is going to query those files, and we're going to get better performance. So look at this. This is thinking about modernization. Why? Because maybe the OLTP is not the only place where you're going to need to query this data. Maybe you want to create an entire analytics/reporting or machine learning environment using Azure Synapse, and you already have the data in the data lake, okay? And you can do the similar process. I've been talking about Azure, but you can do the same thing with Amazon RDS. And I actually written an article with another person here, how to do that with RDS database on Amazon, using Athena to read the data. So you can read this. I put the link here, and you can read the article. It's very, very technical and very, very deep dive into how to do. So you can do it in Azure, and you can do it in Amazon, on Amazon as well. So what is the? Let's talk about the advantages and disadvantages. So again, the data lake blob storage generation 2 is a very cheap storage. I'm going to show the prices next. It can be queried with the Polybase. You get, when you move anything that you move to Azure, to the cloud, you have automatic backups and automatic DR. It's very compressed, so you don't have to pay for a lot of storage. So you get 40, 50% and even more compression rate when you keep data in Parquet files. And like I said, it can be mapped to Synapse and you can do advanced analytics. What are the disadvantages? Again, you have to make sure that you have a lot of maintenance. You have to make sure that you move the data on a regular basis to the Parquet files. Maybe a disadvantage that you need an ETL or ELT tool to move the data from, you know, the relational format to the Parquet format to another non-relational format. Okay. You may have degraded performance, like I said, unless you're using Synapse, and really depending on how much data you fetch, because you do have, you know, the network in between. You need to have strong data, a strong network if you want to bring back a large data set. And Synapse is more expensive than just keeping the data on the blob storage. Okay, so for example, I have a client that needed to archive data that they don't need to query, maybe rarely, and they decided to first just move the data to the data lake store. And then they said, okay, when we need, if we ever need to query this from the OLTP, then we will map everything to Synapse. And this is really very easy to do with Synapse. Just map to the Parquet files. And there is a way. So if you read about this type of export, you need to you can partition the Parquet files as well, so you get better performance with Synapse. Okay, and this is, you need to, when you I will show when we're talking about the pricing, you need to have a storage that is hierarchical in order for the queries to be faster, partitioned. Okay.
We are almost at the end of the session.
Yes, I
minutes?
know. Thank you. I'm looking at my. So let's talk quickly about the pricing. So in terms of pricing, there's a lot of things that we can do, and it's very hard for me to say, okay, listen, this solution is the best for you in terms of pricing. What we do have, we have the Azure price calculator, where you can play with the sizes of the machines and with the type of resource. You know, if you're debating between virtual machine and Azure database and managed instances, you can play with the pricing. Also, you need to make sure that you read about, if you haven't used, for example, managed instances, it has some constraints. For example, you cannot have more than 100 databases. You have sizing constraints on each one of the platforms. So you need to make sure that this is good for you. Just remember that Microsoft and the other cloud providers are making changes constantly. So maybe something that you read last month is already outdated. So for example, in terms of sizing and stuff like that. So cloud is advancing very, very fast. So what you do is, here's the link to the pricing calculator. You just choose one of those, and then it opens for you the resource, and then you can play with what you want. So you can choose the region. You see, this is an example of Data Lake Storage Generation 2. I just wanted to show you the price. Okay, so I've chosen the tier is archive. Okay, so you have a few tiers. Archive means that it's going to be slower. I've chosen 20 terabytes, which is a lot, right? Hierarchical namespace, which is more expensive than the regular one, because that allows me partitioning on the data lake. Performance tier, I have to choose 2, so I've chosen standard because I don't care about performance that much. And look at the price. So you need to compare between keeping a database alive and use it versus this one. So for most organizations, this is nothing. And look, it's 20 terabyte. Okay, this is just an example. This is another example of the serverless Azure database. Serverless means that you only pay for the usage. So you don't actually pay for, you don't have to pay for the entire machine all the time. It's only for what you use. So look at this, okay? Serverless, generation 5. I even chose 4 vCores, which is a lot. I've chosen a specific duration. You have to read about what is each one of these. So I don't have a lot of time to explain. But you need to estimate how much are you going to use this, and look at the price. Okay, so it's the same as the blob storage for data lake. This is nothing, right? Okay, and you have additional things to think about. Okay, really depending on what you need. One of the problems here is that you have no more than 1 gigabyte per database on the serverless right now. Okay, so this is a constraint. So if, for example, you know that your data will exceed that, maybe you will need to partition or move data in smaller chunks here. Okay, and you can still have the backups for longer. So this is it for me. I hope you enjoyed the presentation. I know that I covered the last part a little bit quicker. Let me know if you have any questions.
I haven't seen any question. Very interesting, because I thought using Parquet file would be easier than that, but nice. Thank you.
No, it's very easy.
Yeah, easy, but what about the lineage of the data if you have to remove some data due to regulation and so on?
What do you mean, remove from
because of GDPR, some people want to be removed from the file, and data need to be anonymized and so on.
So this will require you to use a more complicated ETL, right? Really depending, because I did not talk about the way that you copy the data. I just talked about how to store the data. But if you need, for example, you can use a transparent data encryption on the SQL Server side, and then when you move to Parquet file, it will still be encrypted. So you will need to make sure that you have the way back to decrypt, right? Not transparent, sorry, the masking. You can have masking, but you need to make sure that you will be able to query. So this, I'm not sure about the Parquet files, but I think you will need to do that on the application side to make sure that you encrypt and decrypt the data, or remove the parts that you cannot store. So I'm not sure. I think that from regulation perspective, it may be better to keep things in a database format, because you have more options, right? You can encrypt better when you have a database or mask.
Absolutely. Thank you, Michelle.
Okay, thank you very much, and feel free to email me if you have additional questions or comments. And I'm here to learn too, so if I missed anything, let me know as well.
Thank you very much. I will stop the recording right now. If anybody wants to add some comments, feel free to do.